So we want to make sure all this code is copied into RStudio. These are the packages we will require, which we've gone through in an earlier video, but we need to make sure those are all there, and we need to double check that our working directory is correct, that we've set it to the correct place. So that's mine on my U drive, which happens to be the slowest hard drive I think anyone's ever owned. And then this is the location of our Ghost script executable that we need to have with that correct path to it there. I'll just go through a few quick things now. Again, in the guide you'll have it'll go into things in a bit better. This is the rotation. We want the top of the image to be facing north. Removing the blue channel pretty much makes it black and white. This is the range between 0 and 1. Again, that will help make it turn it into the black and white. And here we have our the width and height of the photo. So the other thing to take most note of here is the call gfa.bat that we will edit in the midpoint of this video. We'll edit it and we'll have to put in some coordinates from the photos we've taken. So now I'm going to be going through the steps so that we can do the image processing on our photos that we've captured with our Pi camera. So the first thing we want to do is we want to copy all the JPEGs we've taken into our working directory. So we're just going to copy and paste them, and it's going to take a long time because I seem to have very slow hard drives. What we need to do with these as well is we'll need to go through and do a visual check and delete any of the photos that just look awful and don't look right. So I think the biggest problems I've had with these has been light intensity. So because of where I've decided to situate this camera, when the light is shining directly on the camera, we lose the image seems to get oversaturated, and we lose parts of the trees that we're trying to photograph. And then the other problem has been moisture appearing on the dome, normally early in the morning, and then the other one again has been raindrops on top of the dome when it's raining. So I'm going to delete those photos. You can see here sort of what the moisture looks like. I am using silica gel in the box to keep the electronics dry, but I still seem to get some moisture, especially early in the mornings, forming inside the top of the dome that then dries off by the afternoon. I think with the light with the ones that are oversaturated with light, I think this is just a problem with the sites, because what I've done is I was going to go for proper inverted commas hemispheric photos in a forest stand with mature trees, but I decided that it'd be more interesting to see if it could work and you could get usable data in a situation that might be more similar to a garden or to somewhere. So if you were going to use this system, you could just put it in your back garden and get some interesting data about the growth of your trees, or at the least sort of come up with some sort of model, even though there's going to be a lot of scatter. Anyway, so now we've deleted the photos that are all that were a bit dodgy. So to convert our images into black and white BMP, we need to select the R code down to the point where it says or just before the point where it says note it is necessary to convert the BMP images to 8-bit at this point. So you just select that code, and then in the top right there's a little button that says run, and then you press run, and then it will start off our image processing. So I highly recommend that you follow along with the online guide that's linked at the bottom of this video. That'll go into more detail about some of the settings, but it's important to just take a quick note of the 3 that I'm hovering over, because that is correcting the image, rotating it so that the top of the image is facing north, which is what we need it to do for our gap fraction analysis. Converting these photos into BMP at this stage also takes a fairly long time. I think this took around 16 minutes to process these images. So in the next step, we want to go back into our working directory, and we want to delete all the JPEGs that are left after the conversion. You don't really have to do this, but in the next part we're going to be converting all the images into 8-bit.bmp and inverting them, and if you don't delete the JPEGs, it'll do that to them, and it'll just take longer. The actual analysis won't be affected because it would have just ignored these, but it would just take us, well, twice the time when we come to using ImageJ to convert our images to 8-bit BMP. So we will just make sure that we've deleted all those things, and then we will head to ImageJ, and we're going to convert them into 8-bit BMP and invert them for our gap fraction analysis. The macro is available in the guide, and you can just copy and paste it in there, and then we'll press process. This will take ages. It's like 3 seconds a photo, something like that. So I'll cut the video to make it all a bit quicker, but yeah. So once that's done and those have been converted, and we'll just double check they've all been inverted, and again everything seems to take ages to load in on this hard drive, but you can see they've been inverted, and the file size should all be around a uniform 15,000 kilobytes. So we will just check to see the file sizes, and yep, that looks right. So now we've converted those, we need to go back to ImageJ, and we need to grab 3 coordinates for our photo that we will put into the call gfa.bat. So we'll file open, here's one, and we'll open it. Now we want to take the coordinates, let me just see if you can see it, from effectively a triangular point. Now, because this is on a rectangular background, we're going to lose some information, but we want to take 3 coordinate points on the horizon. So you can take one there, and you see ImageJ gives you the X and Y, and you can note that down, and then one there, note that down, and then one on that horizon, note that down. And so once you've noted those coordinates down, we will then go back to our working directory, and then we will open our call gfa.bat. That should be there. Actually, we'll edit it, because opening it will just try and make it run. And then this here is where we put in our coordinates. So change this to your coordinates. Again, in the guide, this script will be available that gives you both gap fraction and gap size, although we are only running our final analysis on the gap fraction. So this batch file will do that for you. The only other thing here to make note of is these are our azimuth sectors that you can leave the same, or I think just leave them the same unless you really know what you're doing. that's pretty standard. And this is my magnetic declination. So it's set for where I am, which is in West Sussex, UK. If you're somewhere else, you can just look it up online as to what your magnetic declination is. This stuff, that's for gap size that we won't be using. It's going to generate gap size files, but we won't be using them in our final analysis, so you can just ignore that. It was just easier to run both types of both gaps fraction and gap size with this .bat file than just doing one at a time. So once that's done and we've edited our bat file, we can then go back into R and we can run the rest of the analysis. So we will select all of this code and hit run. And again, this will take a certain amount of time. If you note in this output here, you will see the center point of your photo, and that's just a good way of double checking in an ImageJ that you're getting that your coordinates have been correct. If that's way off, then you need to go back in and do your coordinates. Anyway, I'm just going to let this run through. I've made it shorter. It will take, again, a very long time. So anyway, when it's finished, it'll exit out with an error because it's run out of photos to look at and analyze. And then we can load this into Excel. So we will go and search for import. And we will import our text file, our gap fraction results file, into a spreadsheet, so we can have a look at it and see if we get any sort of trend with this early data. I mean, it's only been running a week, so, or just a bit over a week, so we will have a look and see if we can see some leaf growth. Oh, I've decided to use the wrong import function. We need import from text to text/CSV, and that will just load it nicely into Excel. So we'll find the file. It's called GF results file, and you can see all the other files that we've made with our analysis. And then there we go. We'll load it in, and the column we're most interested in is this one, column 18. And we'll copy that. I'm just going to copy it into Minitab quickly, which is a statistical software suite, and just have a very quick look to see if there's any sort of trend line. And hopefully there is. Where are we? Yep, we're just going to go for just a quick look and see if there's any sort of trend line. Obviously, a linear trend line is probably not going to be the best fit for this data. And we can see there is a slight trend going up. We can see a slight trend going up. I think later on I will have a look and try and knock off some outliers. So I'll try and knock off some outliers using the statistical software, and I might go back through and delete more dodgy photos. Also, once I've got a bit more data, a few more days, perhaps another couple of weeks, I'll come back to it, have another look at it and see where we are. But as it is, it does seem like this will give you some sort of model, even if your camera is situated in a really, really non-ideal place. I mean, again, this is designed for large mature stands of trees, but I thought, how many people have large mature stands of trees in their back garden? So I thought I'll find somewhere with some immature little chestnuts and horse chestnuts and next to a wall and see if the data is in any way useful, and it appears right now that it is. I mean, yeah, it's quite interesting. Anyway, thanks for watching, and I will be back with some more data at another point and we can have another look at it. And hopefully this trend will become stronger over time and we will be able to make some sort of model as to the growth of these two little chestnut trees in their very specific location. So yeah, I'm not sure you can extrapolate this data to the rest of the country or even the area, but it'll be interesting.